In this next problem, we're going to want to find parametric equations that describe the motion about the ellipse x squared over 4 plus y squared over 9 equals 1, where the motion is going to begin at 2, 0 and be in the clockwise direction. And it's going to require 2 seconds for a complete revolution. So we have that when t equals 0, x equals 2, and y equals 0, because when t equals 0, we're at the point 2, 0. So our equations are going to be of the form x of t equals 2 cosine of omega t, and y of t equals negative 3 sine of omega t. Why is that? Well, let's think about this for a second. When t equals 0, I need for x to equal 2. The only way that I can have that happen is if I utilize the cosine function for the parametric equation involving x, because the cosine of 0 is 1. Multiply that 1 by 2, and you get an x-coordinate of 2. Next thing I consider is the fact that I need for the y-coordinate to be equal to 0 when I'm at t equals 0. The only way that can happen is utilizing the sine function there, because the sine of 0 is going to equal 0. But now you're probably asking, well, how do I know to make y of t negative 3? Well, consider the fact that when another point on the graph of this ellipse, if I quickly draw it, is going to be, there's negative 2, 0, 2, 0. I'm going to have 0, 3 on the graph, and I'm also going to have 0, negative 3, just drawn in a rough sketch right off the bat. So there I am when t is 0, and I'm traveling in the clockwise direction, so I'm going like this. So when t is down here at negative pi over 2, I need for the y-coordinate to be negative 3. Sine of pi over 2 is 1. 1 times negative 3 gives me the negative 3. Now the next thing I need to consider is, what is omega going to equal? Well, consider the fact that one entire revolution is going to require 2 seconds. That means that the period of the function is going to have to equal 2 seconds. Well, the period t, by definition, is 2 pi over omega. So what I do is utilize that by saying the period is 2 seconds, and 2 needs to equal 2 pi over omega. Well, that gives me that omega has to equal pi. So now I have that x of t is going to be 2 cosine of pi t, and then y of t is going to equal negative 3 sine of pi t, and I have that that's true for t between 0 and 2, and I have my parametric equations.